Okay, so today's section, we're just going to continue what we were doing yesterday. We'll throw in a new thing because we'll actually deal with the chi-squared value today, but also talk about how some of this stuff is computed by hand. So back to the table that we saw at the beginning of the notes yesterday, or the day before. Notice now we have sums that were not in the table before. So it's just summing up the columns and the rows. So the males, we have 210 plus 106 is 216, and so on with the females. The exercise, 110 plus 98 is 208, summing up the exercise there. And then a 400 total. Those are all important numbers that we need there. Now these are our observed values. Now when we talk about expected values, we're going to talk about probability. So notice in this table right here, I took out the numbers. These are my numbers that are going to be now my expected values. And these are the numbers that your calculator computed yesterday whenever we put in the matrix A, but then it came up with its own matrix B. This is how it was doing that matrix B. So if we want to find the probability of a male with regular exercise, those are independent events, so that's going to be the probability of a male times the probability of exercise. Well, we're dealing with 400 people total, so that would be the probability of male, I have 216 males out of my 400 total, and then I have 208 exercise out of my 400 total. So if I multiply those together, that's going to give me the probability of a male that is exercising, but then I'm going to take that times 400 because I have 400 adults total. So this is kind of like my expected value. If I say the probability of getting heads is a half and I do it 100 times, then I would take 100 times a half to get 50, and I would have 50 tails or 50 heads. In this case, I'm going to take this probability from up here times 400 because I have 400 adults, and when I do the math, I end up with 112.32. That's the number that we're going to put in that spot. Now, we would do the same thing to come up with all the other ones. This is male, no exercise, so I have my 216 and my 192. Female and regular exercise, 184 and 208 and 400. Again, just to show you for the females up here, 184 and 208. This is my total females, my total exercise, multiply, divide, and I get my number there. So this right here is kind of the long route, but notice that when you do the math, this 400 cancels out this 400 but leaves one of the 400s. So you can always just simplify it as you're multiplying your two events, so male and exercise, and dividing it by your total. And that's a lot easier to remember. But all of these values down here, these are all the numbers that the calculator would compute. So on the exam, you're not going to have to do an entire table, but they might ask you to find the expected value of male and regular exercise. And so you would do the math, and you'll have a calculator. So actually you could check that answer in your matrix, but you have to show where it comes from. Now, the chi-squared test that we were doing yesterday, I just want to go over with you real quick where that comes from. You are not going to have to do this by hand, although if you are going to talk about the chi-squared distribution in your paper, they do really recommend that you do some of this stuff by hand instead of just in the calculator. So my chi-squared calculated, not the one that might be given to you, is computed by doing this. Now, what this means is it's going to be the sum of your observed frequencies minus your expected frequencies. So the ones that you typed into your calculator minus the ones the calculator computed, or minus the ones that you just computed by hand on the previous page, squared, divided by those expected frequencies. So we'll go through and we'll do a couple of those to see how that looks here. If the variables are independent, your observed and expected values are going to be very similar, which means that the difference of these two is going to be very small, which means that your overall chi-squared calculated is going to be small. If they are not independent, then they're going to differ significantly. This value will be large, and then your chi-squared calculated value will also be large. Like I said, the calculator is going to compute that for us. We're just going to talk about it so you can see where it comes from, and we'll sum up at the end what you actually have to be able to do for the exam. The contingency tables, remember, you are going to have to find your degrees of freedom for that. So that's going to be your rows -1 times your columns -1. And make sure you're not including those sums in those tables if they do give you the sums. So an example here to kind of go through by hand to see how this works and be glad the calculator does it for you. Here's our males and our females, and these are favorite colors of t-shirts. So I'm going to go ahead and get rid of those numbers and over here come up with my sums. So adding up here, I have 150 males, 150 females, and then totaling up my colors there. Now, some of this math is going to look pretty redundant because of the fact that my males and females both add up to be the same. That's not always going to be the case. If I start trying to fill in some of the blanks here on my table, I'm not going to go through all of these with you, but you can go back and look at them later. So if I want to do male and black, I'm going to take my 300 people total times the probability of male. Well, I have 150 male out of 300 times the probability of black. Well, I have 83 black out of 300 total. Again, really those 300s will cancel out, and you can really just look at it like that. That's going to give me a 41.5. Okay. Now let's skip to, say, female in red. So female in red, I'm going to take my 150, I'm going to take my 300 total. I'm going to take my 150 females out of 300. I'm going to take my 58 whites out of 300, which again really essentially is just that. And that one gives me exactly 29. Oops, looks like I did female and white instead. That's okay. We can put that one right there, female and white. And you would do the same thing to get all the other numbers here. Okay, so let's fast forward. We've done all that. We've gotten all those numbers. This, again, is something you have to do on the exam, but they will tell you, hey, let's just do female white. And then you will do the math to show that this gives you the same number, again, that you would see in your calculator. Okay. Now, I'm going to take all these numbers here, all these expected frequencies, not my observed frequencies. These are the observed frequencies. All of these numbers down here, these are all my expected frequencies. Okay, so now I brought them all over here. These were my observed, and these are all my expected. Now here I have the word given. That's the same thing as your observed. Okay, and then we do the formula here. So the formula says we're going to take the sum of my given values minus my expected values squared divided by my expected value. So I'm going to take 48 minus this. I'm going to square it, and I'm going to divide by my expected value. And the same thing throughout all of this. When I do that, and I didn't write out what all that math was, but once I do that and I add them all up, because this sigma means to do the sum, I end up with 33.8. That is the chi-squared value that the calculator gave you yesterday. That's what it was doing. It was computing that other matrix. It was subtracting the numbers in the two matrices and squaring them, and then dividing by the other matrix, and then adding them all up, and that's the number that was popping out there. So none of that math is difficult. It's just a lot, and again, the calculator is going to do it for us. Now, to see where you're going with this is your calculated chi-squared. Okay, so this table, if we do our degrees of freedom, we have 4 columns and we have 2 rows. Now, again, you don't want to include your sum. So I really have 1, 2, 3, 4, 5 rows of number, or 5 columns of numbers, but really only 4 are my data points. So if I find my degrees of frequency, that's going to be 2 minus 1, 4 minus 1. That's going to be 1 times 3. That's going to be 3. So you would look in your table here for, this is the table from yesterday, degrees of freedom 3, and then they'll tell you what significance level that they want you to use. But notice that this chi-squared that is calculated is higher than all of these given critical values. These are the things that will be given to you. And that's what we're going to talk about. We're going to talk about this value, how this value compares to one of these. And again, on the exam, these would be given to you. But this is where they're coming from. They're coming from the given significance level. They're coming from your degrees of freedom. And they're coming from a massive table. Again, we're glad the calculator does that for us. So reminder from yesterday, we're going to write out our hypotheses. We're going to calculate that chi-squared value using the graphing calculator or determine the p-value. Today we're kind of starting to now focus on that chi-squared. They're going to give you a critical value to compare your chi-squared to, or they're going to give you a significance level to use to compare that p-value to. For today, the chi-squared, again, if the chi-squared is high, we're going to reject because it rhymes, and that's kind of clever. If the p-value is low because p is probability, we're going to reject. All right, so we've got first example here. So we've got all of our data points that we're going to put into our calculator. We're going to state the null and the alternate hypothesis, and then we're going to do some of this math here by hand. So state the hypotheses here. Preference of the chocolate cream flavor and gender are independent. These are all different types of chocolate cream. I didn't read the question here. So the preference of this and the gender are independent. That's my null hypothesis. They are not independent. That's my alternate hypothesis. Okay, show the expected frequency for female and strawberry flavor is 16.3. So they're actually giving you the answer right here. But female strawberry. So actually this is the kind of the cell that we're kind of trying to compute here. So my probability of female, I've got 43 females out of my 100. So 43 female out of 100. I've got my 38 strawberry out of 100. To do my expected value, expected frequency here, I'm going to multiply those times 100, or again, we can shortcut that, and that shows 16.34. So approximately, that would be my 16.3. Now, write down the degrees of freedom. Anytime it says to write down, that's something that should be pretty easy. So I do, in this case, have 2 rows, and I have 4 columns. So same degrees of freedom that we had on the last one. Okay. Now write down the chi-squared calculated value for this data. So that's going to be using the calculator. So we're going to go here to the calculator, and I'm going to go to my matrix. And we're going to put in to my table here. We're going to put in a 2 by 4 matrix. And so that's going to be 20. And we're putting in our given values here. So 23, 18, 8, and 8. 15, 6, 12, and 10. Okay. So now once we've got that all in there, we're going to get out of this menu. And we're going to go to our distribution. I'm sorry, no, we're going to stats. And we're going to tests. And we want to go to our chi-squared test. So again, leave all that the same. Calculate. Okay, so this is the p-value that we looked at yesterday, but now we have this chi-squared value. Notice the degrees of freedom back up what we already said. They are going to want you to show work on how you get that degrees of freedom, being that it does tell you that in the calculator. So we go back here. And we're going to jot that number down, 6.88. We're going to compare that to the critical value that they will give us. So the next part, notice they give us that critical value. Now we could get that from our table if they tell us what our significance level is. This is a 5% significance level. So just to kind of go back here a second, 5% significance level, degrees of freedom 3. Here's that critical value that they're going to give me. And here's the critical value that they've given me. So we're going to compare this to our critical value. So this is the number that I want to see if it's high or low. This number is lower than my critical value. So high, we reject. Low, we're going to fail to reject. So which means there is significant evidence to conclude that the preference of chocolate cream flavor and gender are independent, because that was my null hypothesis. Now, if you want to look at the p-value as well, the p-value from my previous screen there on the calculator was 0.0758. If I compare that to 5% significance level, that was given up here in the question, 5% significance level. That's a p-value an alpha of 0.05. So this number right here is greater than 0.05. So again, with the probability, if the probability is low, that's bad. So this is good, that's high. So we're going to fail to reject that null hypothesis. So there's significant evidence to conclude that those two things are independent. Now, this last one here is essentially exactly the same thing. We've got our billiards and our snooker and our darts, which again, that snooker has to do with some kind of billiard game here. We've got our null and our alternate hypothesis, that the preference of the game that you choose and your gender are independent, or that they are not independent. Show the expected frequency for female billiards is 27.1. So female billiards, again, we're doing a number in the same spot. I didn't necessarily mean for that to happen there. But we've got my 52 total and my 60 total. So 52 out of my 115 and 60 out of my 115. If I multiply that times my total for my expected value, that will give me, again, shortcut 52 times 60 over 115 is 27.1. They do want you to show work on that because they are giving you the answer. Where is it coming from? So you could do this shortcut, or if you're more comfortable, you could do it the long way out there. My degrees of freedom, in this case, I've got 2 rows and 3 columns. So 3 minus 1, 2 minus 1 gives me 2. Just realize there I did do that out of order from the formula that I gave you, but the order doesn't matter for your multiplication there. So 2 degrees of freedom. Your chi-squared value, that's going to be from the calculator. So let's put these in here real quick. We're going to edit this, and this is going to be a 2 by 3 matrix. 2 by 3 matrix. I'm looking for my example here. Here we go. Okay, so we've got a 2 by 3. We're going to put in our numbers, those 39, 16, 8, 21, 14, and 17. Okay, so now we go to we'll get out of this. We go to stat and to our test. And we ignore all of this. Okay, so there's our chi-squared value that we're going to carry over. We'll talk about the p-value as well, so we'll carry that number over. The degrees of freedom, that verifies what we found there by hand. So we jot this number down, 7.79. My critical value is 4.605. Now this one was at a 10% significance level. If we want to go back and look at that table, 10% significance level. This time we have a degree of freedom of 2. Significance level 10%, 4.61. That's the number that they're going to give me. I just think it's nice to see where that number comes from. So 4.605 or 4.61 was what we had in the table there. We're going to compare those two. So my calculated value is higher than the one that they gave me. So high, if the chi is high, we reject. So we're rejecting the null hypothesis. There is significant evidence to conclude that the preference of game and gender are not independent. That p-value, this was what was in our calculator. Again, anytime it says write down, that's something that should be pretty easy to do. My 10% significance level, that's the same thing as an alpha of 0.10. We compare, okay, my p-value in this case is lower. A low probability is bad, so we would also reject. Now, you're not going to be asked to do both in the same problem, but you should be able to theoretically do both. This example here and the last one both show you exactly what you would have to do for this on the exam. We do not have to go through and do all that entire table and add everything up and do all of that to come up with the chi-squared calculated. The calculator is going to calculate that for us. Okay. So your homework there is in the book. If you have any questions, let me know.